Hi everyone, in this video we're going through 1F inverse functions. So inverse functions are often on exams, especially exam 1 where you don't have a calculator. They're not that difficult, but they might challenge your algebraic techniques because what you do is you switch x and y and then you need to transpose your equation to make y the subject. So we can only take first of all, we can only take the inverse if it's a one-to-one function. Okay, so that's important to remember. And we use the notation f of -1. All right, so if you ever see f of -1, that's your inverse. Okay, so when we get to doing calculus, try not to get mixed up with antidifferentiation. So f of -1 is your inverse. So our inverse, when you're writing your function, you do need to use the correct notation. You might be tempted just to leave it as y equals, but you must write it as f of -1. Just thinking, what have I written here? Okay, don't worry about that. The domain of your inverse is equal to the range of f, and the range of your inverse is equal to the domain of f. So basically, you're switching x and y, so your domain and range also switch. Okay, because you're taking the inverse, things are basically swapping. All right, so inverse means just the opposite. So x is switching with y, and the domain is switching with the range. Now, basically this part here, what this means is if you were to substitute the inverse into the original function, you're left with y equals x. Okay, and that basically just means your inverse function, if I were to sketch the line y equals x, it just, oh God, it should be a straight line going through the origin like so. So your inverse is just reflected along that line. So if you substitute your inverse into your original function, you actually get the line y equals x, or the equation y equals x. All right, or f of -1 equals x. So it's reflected along that line. So when you're doing your sketching, it does help to remember that it is reflected along that line. So we might do a little bit of sketching today, not too sure. All right, I'm not going to do these. I'm just going to skip to the actual practice questions. All right, so for each of the following functions, find the inverse and state its domain and range. All right, so here we've got a parabola, 2x squared minus 4, and it's got a restricted domain because it's not one-to-one. Okay, so it needs to be one-to-one to take its inverse, so restricting its domain is now making it one-to-one. All right, so when we're doing our inverse, I'm just going to, instead of writing f of x, I'm going to use y. So y equals 2x squared minus 4. Now, when you're taking the inverse, as I said before, you switch x and y. So it's going to become, instead of y equals, it becomes x equals. And then instead of x squared, it becomes y squared. But you can't leave it like that. You do need to take y out the front. So let's just use our algebraic skills, okay, to solve this. Okay, I'm going to do a few steps in one go. So y is, we're going to take the square root of that. When you're drawing your radical, your square root sign, just make sure it covers everything that you want it to cover. All right, so don't be sloppy with your handwriting. I'm just making sure that's right. Now we only want the positive because we're going from 0 to infinity. Okay, so not the negative. So y equals, so we can't leave it like that. If you did that on an exam, it would be marked wrong. You need to change your notation to show that it's the inverse. Okay, so there's your inverse function there. And we do need to state its domain and range. So Haven't left much room. Okay, so let's just go back up here. So remember the domain and the range switch. So we're going to have to find the domain and range of f, and then we will switch them over. Okay, so the domain of f is 0 to infinity, and the range, so if I was to substitute in, oh, you can actually think of this. All right, so it's a parabola, it's been shifted down 4. So we're going from -4 to infinity. You can substitute 0 in there if you like, and you'd get -4. All right, so for your inverse, they just now switch. So your domain is now -4 to infinity. Oops, I should get into the habit of doing the right brackets. All right, and then your range is square bracket 0 to infinity. All right, so they switch. Your x and y switch, and then your domain and range switch. All right, so let's do B and C, although I haven't left much room, I apologize. Okay, so I'll just write over here, y equals square root of -x, and then we're going to switch x and y. So we're going to have x equals the square root of -y. So to get rid of the square sign, we're going to square both sides, and then I'm going to get rid of the negative too. So we're going to have y equals -x squared, and I need to now not use f because the function is h. All right, so h of -1, just be careful not to do that. And what was that? -x squared. All right, so your domain of this one is negative. So let's just, so we're running out of room. So remember, they switch. So if your domain for your original function is -r, so that's going to be, and then your domain was, sorry, not yet. The range of h is, so if we were to substitute anything into there, we would get a positive answer because we're going to have a negative times a negative gives us a positive. So you got the square root of a positive, it's going to give you a positive. So we're going to be from 0 to infinity. All right, so what I just did there, instead of separating it like I did in question 1, I just did it in my head. So your domain for h is r negative. So that now becomes our range for our inverse. And then the range of h of x, so the square root of -x, the range is 0 to infinity. So that now becomes the domain of our inverse. Okay, so remember they switch over. All right, let's do C. So we're going to have y equals, now if you want to at the start, you could do y equals the inverse of g. Okay, so you've already defined it. So y equals, actually, probably shouldn't have put it there. But anyway, always remember to do it at the end. All right, so we've got x plus 1 squared, so we've got to switch x and y. All right, so we're going to take the square root of both sides. Okay. Now I'm just thinking when we take this square root, we do have a positive and a negative, but we've restricted the domain from -1 to 3. So if we think about this parabola, oh gosh, I'm running out of room here. So it's been shifted, yeah, so -1, yeah, and then 3, substituting 3 for, okay. So your parabola looks something like that. So it's just restricting the domain so it becomes 1 to 1. All right, so we've got y equals the square root of x minus 1. Now I'm just being cautious with that domain though, just to make sure. Yeah, okay, so it's not the negative. All right. And then we need to write G. Sorry, I'm thinking at the same time. All right, so if we've got this graph here, it's probably good that I did graph it. So remember I said earlier it reflects over the line y equals x. So this is probably not the best one to see, but this point here, which is -1, 0, now becomes 0, -1. Okay, so that's where our graph is going to begin. And then I can put the 3 up here. So the graph is kind of like a reflection along that line. Okay, so you can see it there. Maybe I'll put it on the calculator. Might look a bit better. All right, so what did we have? Our original one was x plus 1 squared, and then we had square root of x minus 1. I want to graph both of them. Oops, I didn't restrict the domain. Let's restrict the domain. What was that? -1. Not. All right, so you can see it maybe a little bit better if I maybe put the graph y equals x on there as well. So you can see how it's reflected. So my graph, it's quite a sharp increase. Okay, so you can see that, but you can kind of still see it's reflected. All right. What do we have to do? Oh, we do have to do the range and the domain and range. Okay. All right, so remember the range is going to be the same as the domain of the original function, so -1 to 3. And if I was graphing this, I probably should also have open circles here, which I didn't put, but I just noticed the curved here. And then if I was to draw the end, I would also have to have open. So I say curved circles? Open circles. All right, sorry girls. Then your domain, so the domain of the first one, so we're going, sorry, the range of g of x, oh my gosh, I'm not functioning too well today. So the range.
Good morning, everyone. As some of you have...
All right, so Miss Mangelsdorf just wanted to say good morning to you, everyone. So good morning. All right, so our domain, sorry, let me just think again, where was I? So the range of g of x, so if we look at g of x, remember that's our top one. We're going from 0, but it's not included because the -1 isn't included. And then when we substitute 3 into here, we go up to 16. And that's also not included. Okay, so just be careful with your brackets. All right, how we go? Oh gosh, we've got heaps to go. All right, number 2, find the inverse of each of the following. All right, so we've got the restricted domain, so r can't be equal to 3, and that's because if we were to substitute in 3 into for x, it's undefined because our denominator will be 0. All right, so let's write it y equals 1 over x minus 3. So switch your x and your y. All right, and then we're going to have x times y minus 3 equals 1. Y minus 3 equals 1 over x, and then y equals 1 over x plus 3. And remember, we do need to use the correct notation. All right, so there's our function. I'm not going to sketch it. You can sketch it on your calculator and you can compare it to the original one to show that you've got the inverse. All right, part B. Okay, so again, we've got the restricted domain because we can't take the square root of a negative number. All right, so we've got y equals the square root of 2 minus x plus 1. So, oops. So what we do first is switch x and y. Okay, so x minus 1, 2 minus y. So we're going to have x minus 1. Get rid of the square root signs. We're going to square both sides. 2 minus y. And then that's going to be y equals 2 minus x minus 1 squared. And don't forget, we can't leave it as y, so it's going to f negative 1 of x equals 2 minus x minus 1 squared. Now, I haven't been checking my answers as we go along, so hopefully they're all correct. All right, question 3. So this time we've got a domain in terms of b. So it's probably going to ask us to find b. All right, so where g of x equals x squared plus 4x, if b is the smallest real number such that g has an inverse function, find b and g of negative 1 of x. Okay, so what we've got here is a parabola. So I'm going to write it over here, y equals, and I'm going to factorize it because I find it easier to sketch if we're factorizing x. I've got x plus 4. All right, so x equals 0, x equals negative 4. All right, so we know our x-intercepts. The turning point is halfway between our x-intercepts, so it's going to be at negative 2. When I substitute negative 2 in, what do I get? Negative 2 plus 4 is 2 to negative 4. All right, so just, oh gosh, that's a terrible 4. There we go. Just a rough sketch. All right, so we want to go from b to infinity. So we got to cut it in half to make it 1 to 1. So remember, b is your restriction on your x, or your lower bound on your x. So it's going to be negative 2. So b has to equal negative 2, because then we're going to up to infinity. If it was negative infinity to b, actually it wouldn't make any difference. All right, so b equals negative 2. All right, so when finding the inverse, sorry, I had a huge break in between, so if it was a bit disjointed, that is why. So when we're finding the inverse, let's first of all factorize this. So we've got x squared plus 4x. If we were to just switch x and y, it's going to be very complicated. So to make it simple for us, or simpler for us, we can complete the square, and then it's going to put it in a form that's going to be easier to find the inverse. So I'll just show you first of all if we weren't to complete the square. So let's say I did. So switch x and y. All right, so getting it in this form, you're going to think, well, how can I get y on its own when we've got y in two terms? So what we need to do is complete the square. You can either complete the square from the beginning with the x's, or you can complete the square here with the y's. So I'm just going to do it with the y's because we've already got it written there. All right, so completing the square, it's going to test my memory. Okay, so x squared plus 4y, then we halve the coefficient of y. So half of 4 is 2. And then we also subtract that. All right, so effectively what we're doing is we haven't changed the function at all. Okay, we still got the y squared plus 4y, but so we can complete the square, we've got to add this constant 2 squared. Now, we can't just add it because that's going to change the equation. So we've got to also take it away. But if we just look at the first three terms, if we were to factorize that, we would get y plus 2. Actually, what am I doing? I'm probably not doing it the easiest way. Let me just, anyway, we'll just leave it like that. So y plus 2 squared is the factorized form of y squared plus 4y plus 4. Okay, so you can expand it and you'd get the same thing. But then we've got the minus 4 on the end. All right, so all we're doing is completing the square. The reason we do that is now instead of having two terms that contain y, we've just got y on its own. All right, so now we can bring that minus 4 over as plus 4. So x plus 4 equals y plus 2 squared. Take the square root of both sides. And then we're left with y equals square root of x plus 4 minus 2. And don't forget, we can't leave it as y, so we've got to go back to our original function g, but it's the inverse, so it's g to the negative 1. X plus 4 minus 2. All right, so there's our function. Now our domain for this is the same as the range as our original function. So remember our range for the original function, we've gone from negative 4 to infinity. So this one's going to be from negative 4 to infinity. All right, just make sure that's all good. All right, question 4 is quite similar. So if you want to have a go at doing this on your own, that's fine. Remember the first thing we did to find B in the first question or A in this question is to actually sketch the graph. So what I have here, if I was to factorize that, it would give me an x-intercept at 0 and another x-intercept at 6, making the halfway point 3. So I'm doing that for our turning point. Substitute in 3, so it's going to be 9 minus, that's going to be negative 9. All right, so there's our turning point there. Now, I'm just sketching the graph, but remember our domain is going from negative infinity to a. So we're not wanting, just delete all that. We're going from negative infinity to a, so we're only wanting that part of the graph. Okay, so remember, so that must mean a is equal to 3. All right, so let's go ahead and find the inverse. So f of x is equal to x squared minus 6x. Now you can complete the square now, or you can switch x and y and then complete the square like we did in the previous one. But I'll do it here so you can see both ways. So x squared minus 6x. All right, halve the coefficient of x and square it. So it's going to be plus negative 3 squared and then minus negative 3 squared. The reason I leave it with the negative 3 in brackets is because that just helps us realize what we're going to have inside our bracket. So it's x minus 3 squared. Okay, so if I wrote 9 there, I might forget that it's a negative 3 in the brackets. It's actually, and I might think it's a positive 3 instead of a negative 3, but keeping it as a negative 3 there reminds me, okay, when I'm completing the square, I put negative 3 inside my brackets. And then I've got minus negative 3 squared, so it's minus 9. And this is also turning point form, so I can also see that my turning point is at 3, negative 9, which we can see here, which we did before. Okay, so that means y is equal to x minus 3 squared minus 9. So all I've done is taken our equation in an expanded form and put it in turning point form. All right, so that's makes it a bit easier to find the inverse. So let's just switch x and y. All right, so just doing some transposing. I'm going to take the square root. So y minus 3 equals the square root of y plus 9. What did I do? X plus 9. So y is equal to x plus 9 plus 3. Make sure that your square root sign clearly stops at 9, and then you've got the plus 3. And then we've got the correct notation at the end. All right, so for the domain, so remember the domain is the same as the range of our original function. So the range of the original function is going from -9. Now, I remember before that a wasn't included, so that has to be a curved bracket. And we're going to, oops, did it around the wrong way. Should do infinity first, negative infinity to -9. Actually, no. What am I doing? Just bear with me. I was right the first time. Okay. All right, and I might just check the previous one was, yeah, B had, I just wanted to make sure B had a square bracket in it, so I didn't need to correct that. Yeah, so remember your domain of your inverse is the same as the range of your original function. So the range of this function that I've sketched is -9 to infinity. If I was sketching that, remember that has to be an open circle there. All right, for the question 5, I've just already done all the questions because the video was becoming very long. Sometimes when you take the inverse, it's the same as the original function. So remember your graph and your inverse actually reflect along the line y equals x. So what we've got here is a hyperbola. If we just sketch it, where's my calculator? All right, so I might just sketch it. Oh, did I just have that up? No, 3 on x. Okay. Now, if you think about the line y equals x, because remember they're reflected along that line, it's going to be the same graph. All right, so that's why the inverse is the same as the original. All right, so then we've got B, so we've got a cubed root graph. Now, just be careful with a cubed root graph. You can take this cubed root of a negative number. So I strongly encourage you to always graph things. It's a bit easier to see what is happening if you're graphing it. Oh, what am I doing? Okay, let's go back here. Press the wrong button. So we want the cubed root. Oh, where's the cubed root button? The cubed root is this, there we go. Could have done to the power of a third. I couldn't find that button. X plus 2 and then minus 4. Whoops, minus 4. Excellent. You can see it's already changed it to the power of a third. All right, so you can see the graph there. And the domain of that graph is R. All right, so that's why our domain for, your domain is R, but your range was also R. So the domain of your inverse is also R. And then we've got C, so you can just maybe have a go at doing these on your own and then checking your answers. And then question D. I don't think there are any tricky ones there. The 2 tricky ones were probably these 2 we did before. All right, we'll leave it there. Bye.